The goals of this lab will be to use the mole conversion factors to convert grams to moles and moles to grams. So you get to actually use that. The other thing, we're going to be experimentally determining the simplest formula for an oxide of magnesium. So this is the document that you'll download, and this is our discussion. You're going to be finding the simplest formula. In this experiment, magnesium metal is heated to a high temperature until it reacts with the oxygen in the air. You've already done this reaction once. You did it last week, but this time we're going to look at it in a little more detail. So at the beginning of the experiment, you'll obtain the mass of the magnesium metal. At the end, you'll determine the mass of the oxide product. The mass of the oxygen that combines with the magnesium is the difference between the mass of the oxide product and the initial beginning mass of magnesium. So the grams of oxide product minus the grams of magnesium will give you the grams of oxygen that were added to your product. The simplest formula of the magnesium oxide product can be determined by calculating the moles of magnesium and the moles of oxygen using their respective molar masses. So the moles of magnesium are going to be equal to the grams of magnesium divided by the molar mass of magnesium, which is 24.3. And the moles of oxygen will be determined by taking the grams of oxygen and multiplying and dividing by 16. So the simplest formula will be obtained by dividing the number of moles of the elements by the smaller number of moles. Okay, so this is just kind of like a math trick. What you're going to do is, if, for example, I've got an example here of 0.04 moles of zinc and 0.80 moles of chlorine. So chlorine. So you can't have partial numbers like that. We want small whole numbers. And the trick to get small whole numbers is to take them and divide each of them by the smallest one. So these two numbers, the 0.04 is the smallest. So if we divide both of them by the 0.04, we take our moles of chlorine and divide by 0.04, and we take our moles of zinc and divide by 0.4, we get small whole numbers. You get 1 mole of zinc and 2 moles of chloride. And so then we can write the subscript of zinc chloride. And so we'll have 1 mole of zinc for every 2 moles of chlorine. So this is your experimental procedures. You'll find those online with Late Night Labs. I thought that was easier than trying to toggle back and forth. Basically involves taking your magnesium, weighing it carefully, heating it up, and then weighing your product. So these are your directions. And this is your report sheet that you'll turn in. You have one pre-lab question: what is the simplest formula of the compound? This is the mass of the empty crucible and the cover. You want to make sure that you click on the crucible and tell me what the magnesium looks like before it's burned. This is the mass of the crucible, cover, and magnesium. Goes here. Make sure you put units on that because it looks like I left grams off. And this is the mass of the crucible, cover, and the oxide product. And then you need to write the appearance of the oxide product. Does it look different than it looked initially? Okay. We begin our calculations. The mass of the magnesium will be the mass of the crucible, cover, and magnesium minus the mass of the empty crucible and cover. The mass of the magnesium oxide product will be equal to the mass of the crucible, cover, and oxide product minus the mass of the empty crucible and cover. Make sure you write down all your digits on all this. Okay. So now we've got the mass of the magnesium and we've got the mass of the oxide product. If we subtract those two, we'll get the mass of the oxygen in the product. And then we'll need to calculate the moles of magnesium. You need to show your calculation here. I have demonstrated the calculation on the first page. So you'll take the mass of the magnesium from here and use the molar mass to write a conversion factor and calculate the moles of magnesium and moles of oxygen. Okay. Well, you still won't have small whole numbers. You'll have to take the smallest one, do that here. You'll have moles of magnesium and moles of oxygen. They will not be small whole numbers. What's the smaller value? You're going to divide both of the numbers by the smaller value, and this will give you small whole numbers, and you'll be able to write the formula. And then I've got some problems for you to do. The sections refer to the Timberlake book, which if you're taking the class online, you have a copy or access to that copy, to a copy of that book. So if you need to do some review or some reading to help you out with that. And y'all have a great week.